next term is work input. Work input is the work done by the machine. The work done on the machine by the effort. The work done on the machine by the effort is called work input. Work done by effort on the machine. So, work done का formula force into displacement. So, effort into displacement or effort gives you the work input. The next term is work output. Work done by the machine on the load is known as work output. That is represented by work done on the load by the machine, L into DL. The next important term is efficiency. We need to know how efficient the machine is. So efficiency is the ratio of the work output to work input. Work done, work obtained from the machine, that is work output, upon work exerted on the machine, that is work input. So efficiency is the ratio of work output to work input. Again, efficiency is a pure ratio, work upon work. It has got no SI unit. It is a simple ratio. Okay, so work efficiency is a simple ratio. It has got no unit. Clear? Now, every machine efficiency determines what is the work output with respect to the work input done on the machine. No machine in practical situation can have efficiency equal to 100%. Okay, no machine can be 100% efficient. And that is the condition only in the ideal case where there is no friction between the parts of the machine. The parts have got no mass and they are completely rigid. Okay. Principle of machine. When energy is supplied to a machine by applying effort, it overcomes the load by doing some useful work on it. The point at which the energy is being supplied is known as the effort point. The point at which energy is supplied by applying any effort is known as effort point. And point where the energy is obtained to overcome the load is known as the load point. Therefore, input energy is equal to effort, work done at the effort point. Work done by the effort point. So, work done by the effort point is effort into displacement of effort. Then output energy is equal to work obtained at the load point. That is load into displacement of load point. Displacement of load point. For an ideal machine, what do you call an ideal machine? The input energy is always equal to output energy. So an ideal machine is a one where the output energy is equal to input energy. Now in the case of a machine, the output energy can never be greater than the input energy. Otherwise, what will happen? It will not obey the law of conservation of energy. Therefore, in the case of an ideal machine only, we find that the output energy is equal to input energy. The output energy can never be greater than input energy. In real machines and actual machines, the output energy is always smaller or lesser than the input energy. That is, work output is never equal to work input. That is due to different reasons. What are the reasons? The moving parts. When a machine is made up of moving parts which are neither weightless nor smooth, so there is certain friction. Some amount of energy is lost in overcoming this friction. The strings that are used in the machine are not perfectly elastic. And the third one, the different parts of the machines are not perfectly rigid. So, no actual machine can be 100% efficient. if we say the machine has got 80% efficiency, it means that 80% of the input energy is obtained as the output energy. Next, we have a relationship between mechanical advantage, velocity ratio and efficiency. Mechanical advantage, velocity ratio and efficiency of a given machine. So we know that we have work input. What is work input? Work input is effort into displacement of effort point. Work output is load into displacement of load point. We have the efficiency is equal to work output over work input. So we substitute the value of work output L into DL, displacement of load point, upon effort into displacement of effort point. Now load upon effort we know is mechanical advantage, and displacement of effort upon displacement of load is velocity ratio. So it is reciprocal of dl upon d is reciprocal of velocity ratio 1 upon Vr. So we get the relation efficiency is equal to mechanical advantage into 1 upon velocity ratio. Okay, this is a very important derivation often asked in the examination. I am saying it once again. We put the values work output over work input, which is equivalent to efficiency. This eta is the sign for efficiency. We substitute the formula in the formula load upon effort, which is equal to mechanical advantage, into displacement of load upon displacement of effort, which is the reciprocal of velocity ratio. So efficiency is equal to ma upon Vr. In the practical conditions, when you talk about the practical situations, in that case the efficiency is 100, not 100%. The efficiency is 100% only in the case of ideal machines where there is no friction. In that case, 100% means eta efficiency will become equal to 1, and then which implies that ma equal to Vr. This is for ideal machine. This is for ideal case. In case of ideal machine, efficiency is 100%. So ma equal to Vr. Velocity ratio becomes equal to Vr. And for practical, eta is always less than 1. In that case, velocity ratio will always, mechanical advantage will always be less than velocity ratio. Okay. In practical situation, mechanical advantage will always be less than velocity ratio. Reason? Due to some loss of energy, due to friction, mass of the body, strings which are inextensive. Levers are the simplest kind of machines. What is a lever? A lever is a straight or bent bar which is capable of rotating about a fixed point. What is a lever? Lever is a straight bar or bent bar which is capable of rotating about a fixed point. Next we have principle of levers. What is the principle of lever? Principle of lever. Since I have told you that a lever is a bar which is capable of rotating about a fixed point. So let us take the fixed point. This fixed point is known as fulcrum. And there are two forces that are acting at the extreme end. One is load. One is effort here, another one is load. Now we are talking about the principle of lever. Principle of lever is principle of lever. Principle of lever is the principle of movements about the fulcrum of each force. The movement of effort about the fulcrum and the movement of the load about the fulcrum should be equal. This is the principle of lever. The movement of effort about the fulcrum and the movement of the load about the fulcrum should be equal. Now you know what is movement. Movement is a force into perpendicular distance from the line of action of force. So this is known as principle of movement, or otherwise we can say the clockwise movement should be equal to anti-clockwise movement. Now for this this is the point, this is known as effort point. This point is effort point. The distance of fulcrum to the effort point is known as effort arm. This is known as effort arm. And the distance of the load to the fulcrum is known as load arm. So, movement. This is movement here. This direction is anti-clockwise and this direction is clockwise. So, according to principle of movement lever, we have effort into effort arm equal to load into load arm. Now, effort, we take this effort arm load upon effort is equal to effort arm upon load arm. Now what is load upon effort? Load upon effort is mechanical advantage. So mechanical advantage of a lever is effort arm upon load arm. So we calculate the mechanical advantage of the lever. Mechanical advantage of a lever is effort arm upon load arm. Okay. Now, next we have three conditions that will arise due to the this formula, that is about the mechanical advantage of a machine. Mechanical advantage has come out to be equivalent to effort arm upon load arm. Now, mechanical advantage can be greater than 1. First condition. Second condition, it can be equivalent to 1. Or third condition, it can be equal to or less than 1. So, there are three conditions. Mechanical advantage of a lever can be greater than 1, less than 1 or equal to 1, less than 1. So, when can mechanical advantage be greater than 1? If effort arm is greater than load arm. If effort arm is greater than load arm, then mechanical advantage is greater than 1. In this case, the lever will behave like a force multiplier. Okay? This lever will behave like a force multiplier. So, less amount of effort will be required to lift a heavy load. Then, if mechanical advantage is equivalent to 1, this will happen when the effort arm is equal to load arm. When both the arms of the lever are equivalent, both these distances are equal, in that case mechanical advantage will be equal to 1, and these kind of levers are used only to change the direction. And the third class of lever is when mechanical advantage is less than 1. This will happen only when the load arm is greater than the effort arm, or effort arm is smaller than the load arm. In that case, the value of mechanical advantage will be less than 1. Now, these kind of levers are used for gain in speed. Okay. Now, we will classify the levers into three categories. So, classification of levers we will discuss in the next video.